Hey everyone, welcome to part 2 of section 1.2, 3 examples of limits or things that may not be limits. But first, here is your trivia question. What Oscar-winning film finds Raymond annoying Charlie by passing gas in a phone booth? And the answer at the end of this section. Alright, we're going to first talk about a whole, and here's example 1. Find the limit as x approaches 4 of f of x, where f of x equals x when x isn't 4, and 0 when x is 4. So this is two types of functions. There's kind of two functions put all together. So what we're going to do first is that when x is 0, y is 0, or f of x is 0. When x is 2, f of x is 2. When f of x is 4, it's actually at 0, but according to this, it would be at 4. So I'm just going to put an open circle there. And if it was at 5, it would be at 5. So then I can just fill this in, and I can make a line here. Alright, the only problem is with this line, I have to skip over that one spot. So there's this one right here. And then the other one is going to be, let's say, in orange. So when f of x is going to be 0 when x equals 4. So I'm going to find 4, I'm going to put this spot right there. Okay, so now what we have is, I'm still there, but I'm actually moving my hand. See, I've got the blue marker, and there's no blue marker there. Interesting. So what we have here now is that I go from the left side as I'm approaching this way, and I'm going from the right side as I'm going this way. What number am I getting really, really close to? Well, I'm getting really, really close to 4 when x equals 4, right? So the limit as x approaches 4 of f of x, let's just do that, there we go, is going to equal 4. So even though it doesn't actually approach that number, we know that when x is 4, it approaches something else. When we get from the left side and to the right side, as we kind of squeeze to the middle, there we go, we know that it's going to be right at 4. So we're going to say the limit exists, it's just right there. Alright, so there is our first example, and here's your first assignment. Find the limit as x approaches 2 when f is defined by this. F of x equals 1 when x does not equal 2, and f of x equals 0 when x does equal 2. So we'll do that first assignment. Also, I'm going to have a whole bunch of a list of things for you about how limits don't exist for this next section coming up. So, two types of limits that the limit does not exist for Mean Girls, or they don't have a limit. So here's one. As I go from the left, it approaches here, but as I go to the right, it approaches here. If you remember the car video, it's where there was one above and one below, and the cars were not going to intersect. So if I approach a value on the top that's different from the left than it is on the right, it's not going to exist. So that we could say this limit does not exist. Alright, now there are two other ones that we can look at first. And both of these are called unbounded functions. They just look a little bit different. If we go from here, and I'm saying what is the limit as it approaches this x value right here, let's say it's a -1. If it keeps on going up from the left and keeps on going up from the right, you could say they both are going to infinity. But because infinity is not a real number, we're going to have a real problem. So that way we say the limit does not exist for when both of them are going to the same place, and they're both going up to infinity. Alright, and it also goes for this one. This one's going to positive infinity, this one's going to negative infinity. Then, we also know it's kind of like this first one, where we're just going to say it goes up and down, they're splitting, so that means they're not going to have a limit, because they're going in opposite directions. Alright, so even if they're going in the same directions, if they're both going to infinity, the limit does not exist. There is some debate in the math world about that, but we're going to say the limit does not exist. Alright, so here is our next example right here. And it says, find the limit as x approaches 0 of 1 over x squared. So I'm going to do, instead of having the graph this time, let's use a table. Sounds good to me. So when x is -1, 1 over -1 squared is going to be 1. And the same thing for here. So because it's squared, each one of these opposite values, positive and negative, should be the same. So if I take 1 over 100, 1 over 100 squared is 1 over 10. 1 over 10 squared, which would be 100. So it's going to be negative 1 over 100, which is same as positive 100. All right, if I take 100 squared, 100 times 100, so it's going to be 4 zeros after the 1, and it's going to be 1, 1, 2, 3, 4. And the same way here. Okay, so what you see is that this one's going from 1 to 100 to 10,000 in the same way for the other one. So if I just kind of make a very rudimentary graph, we know, oh, hey-o, we know that they are going to be going up and up. Okay, so we know that they're both going to be going up, and that's going to look like that one where they're both going, and they're both going to infinity from both the left side, and this would be the left side, and this would be the right side. So we know that they're both going to infinity, so we can say the limit does not exist, because they're both going to infinity from the left side and the right side. All right, here's your assignment number 2. Show the limit x as x approaches 0 of absolute value of x over x does not exist. All right, and here's the last kind that you didn't see, and it's called oscillating behavior. So what we're going to do is I'm going to show you the graph. We're going to talk about f of x equals 1 over, or cosine of 1 over x. We're going to find the limit as x approaches 0, because we know that divide by 0 is going to give you an error. So what we have is, let's get this one all set. Now I'm going to set my minimum and maximum to -1, -1, +1, and there we go. So can you see that very well? Sure you can. And I hit graph, and it goes down, comes back up, shakes around a lot, goes back down, and comes back up. So it looks like if we were to zoom out, this would not be a big deal. But as we zoom in, as x gets smaller, or as x gets smaller and smaller and smaller, that really means we're going around the unit circle faster and faster and faster. So it's going to become oscillating between the top and the bottom. It's going between +1, -1, +1, -1, +1, -1, +1, -1. As we get closer and closer to 0, it just happens faster and faster and faster and faster and faster. So what we can say is that we don't have a limit, because it's going, if I zoom in really, 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 really close, so here's 0, and here's like 0.000001, it's just going up and down and up and down and up and down and up and down and up and down, and it just keeps on going faster and faster until it's like here and here and here and here. It's both at +1 and -1, and then we start to do the same thing again, and it starts to even out. So it's going faster and faster as it's getting closer and closer to 0. So we don't know, is it -1 or is it +1? So since we don't know, we're going to say the limit does not exist. All right, so that limit does not exist. So here is your last assignment. Does the limit exist as the limit as x approaches 0 of sine 1 over x? It might be different. You'll have to check it out. And of course, you can use your graphing calculator or any other calculating device that you have. So here are some things you probably want to write this down. This is a good thing to get into your notebook. Common behaviors associated with non-existence of a limit. 1. F of x approaches a different number from the right side of c than it approaches the left side. Remember, c is what x approaches, so as x approaches c, we're talking about that value. All right, so as x approaches c, it's different from the left side as it is the right side. Looks like that. Number 2, f of x increases or decreases without bound as x approaches c. It's the one where they both go this way, or the one where they go that way. All right, and the last one, f of x oscillates between two fixed points or values as x approaches c. So it's kind of going between here, and then they just switch, and they keep on going faster and faster and faster like that. All right, there you go. So that is the assignment from section 1.2, Existence of Limits, and your trivia question, which again was, what Oscar-winning film finds Raymond annoying Charlie by passing gas in a phone booth? And the correct answer is Rain Man. All right, thank you very much. Good luck.